Hello, today we're going to be presenting on phone charger failure analysis. Our group is Nathan Kraft, Elijah Kurt, and Dex Jack. So to begin with the motivation and relevance behind this project, it's a very common issue today with most chargers having only an average lifespan of about 1 year. This can be annoying to deal with, and a lot of people have this problem. It also pertains to our coursework and things like cyclic loading, fatigue analysis, and stress concentration. Additionally, here are some of the copper's material properties, as this is what's inside of the wire. Here's the ultimate tensile strength, yield strength, endurance limit, elastic modulus, and fatigue stress fraction, which we assume to be 0.9, as well as the copper wire diameter, which is 0.1 millimeters.
The wire experiences a cyclic loading that is caused by bending, and so we made the reasonable assumption that the loading is pure bending, which simplifies calculations a little bit. And so the goal was to find our amplitude stress and our mean stress. We used these two equations on the bottom, along with the copper wire properties from the previous slide, and we got that our amplitude stress is 156.9 megapascals, and our mean stress is 78.5 megapascals. The mean stress is exactly half the amplitude stress because this is pure bending, so we can just divide it by 2. This red area here is where the majority of the stresses gets concentrated to, and just with the way this is bending, we can see this 35 millimeter radius of bend that we used in the previous calculations. And so therefore this red area is what normally fails first, just because it's a weaker part of the wire and it's experiencing so much stress. And then normally, because this outer rubber housing has like a larger diameter than the inner copper, the outer part fails first, and then the wire itself still works, but normally the inside fails shortly after because its protective layer is all gone.
During the life cycle of the phone charger, it is important to understand that the stress being examined here occurs from an extreme bending angle. If the angle was gentler, the wire would be able to survive for longer. The Goodman criteria is used here to determine if the system can survive an infinite number of cycles using the amplitude stress, mean stress, endurance limit, and ultimate strength. The factor of safety is found to be 0.4 with this loading, so the wire should not have infinite life. A and B are necessary to find the number of cycles that the charger can withstand. These values are found using the shown equations along with the fatigue stress fraction, ultimate strength, and endurance limit. Then, the equivalent completely reversed stress is found using the amplitude stress, mean stress, and ultimate strength. These values can be seen above their respective equations. Using the final equation, we can find that the number of predicted cycles before failure is around 222 cycles. Options to prevent failure in the charger can be seen here. You should be careful with how you rest the charging phone, or you can buy a plastic sleeve for the wire. The charger design can include fillets to reduce stress concentration. Finally, you can remove the charger by grabbing closer to the plug, which will prevent the rubber protecting the wire from becoming damaged. Without this protection, the wire can be subjected to corrosion, reducing its lifespan significantly.